Hello, welcome to our webinar. We will be waiting another 3-4 minutes to start and we will continue. Hello everybody, this is Safak and today we are going to talk about Delta Lake and structured streaming. Before we start, I would like to introduce EPAM and our big data team. So as you know, we are one of the biggest consultancy companies, and for EPAM Spain, we are growing in numbers and we are doing a lot of interesting projects, and we are working on the new technologies and working on the cutting edge of the technology. So let's start. Okay, so today we will be talking about mostly Delta Lake and structured streaming. But before we start, I would like to give you very brief and very quick introduction about Apache Spark. Then we will be talking about Delta Lake. We will have 3 demos. One of them will be about Delta Lake. Then we will talk about structured streaming. After that, we will be doing structured streaming demo, and we will be using real life data, which is from OpenSky network, and I believe it will be cool. Let's see. I would like to introduce myself. As you know, my name is Safak, and I am lead software engineer in big data domain since 2015, and I'm mostly focused on streaming projects. I have completed more than 10 projects in big data domain. I'm doing the trainings for last 5 years, and I'm an aviation geek. Okay, so I would like to start with Apache Spark, and it will be, I promise it will be very short. So basically, why do we need it? Spark is fast. When I say fast, I'm comparing with Hadoop, the legacy system. It is faster than Hadoop and like 100 times faster because it is able to do the process in memory. And the most important feature for us, it supports multi-language. I mean, we can code with Scala, Java, Python, even with R. And machine learning libraries are ready to use for Spark. So you don't need to deal with, implement some algorithm, some fancy stuff. It's already there. You just need to get it and use it. Also, it can connect multiple data sources easily, like including HDFS, Cassandra, Hive, HBase, whatever you can name. There's a connector for us. And also the Spark SQL part is one of the crucial part for us. And like I mentioned, the Spark streaming is there, graphics, and we have extra packages. Okay, the main topic for today is, of course, Delta Lake. This is a new generation of data warehousing. I'm saying new generation because we were using Hive and other technologies to store our data, right? But now Databricks has introduced a new component for us, which is called Delta Lake. Why it is important for us? Because we need to be fast and we need to be scalable, and this should support ACID. This is the most important benefit of having Delta Lake. As you can see, there are several stages, but and it shows us the aggregated data. So basically, we can send the data from streaming or batch to the Delta Lake. Then at the end, we can get aggregated and ready to use data. And we can use let's switch the slide first. Yes. So yes, Delta Lake, but why? Because like I said, the most important feature is that it supports ACID. So what does it? ACID, I believe we are all familiar, but let's repeat. Atomicity, consistency, isolation, and durability. And this was very, very problematic when you are working with in big data technologies. For example, Hive also have some kind of feature which is called ACID tables, but Spark doesn't support it natively. So if you would like to use Hive ACID tables, you need to do some extra stuff and you need to check what is wrong, how should do the partitioning and so on. Delta Lake, it's not a separate service. It's just an not implementation, but integration of a Spark. So basically, whenever you are starting your Spark, you need to say to Spark engine that you are going to use Delta Lake, and that's all. And this has been designed for mostly Spark. And this is quite important. So if you say that, okay, I would like to use Delta Lake separately, it could be a problem, right? Time travel. This is also quite important. If you are familiar with HBase, you know that HBase has this versioning, but you need to enable it and you need to keep it. You need to do maintenance by yourself, and it could be real problem. Whenever you are checking the versions, you need to keep track of it, and you need to, set version numbers and so on. But Delta Lake by default supports time travel, this data versioning. Open format. So what does it mean? We are using Apache Spark under the hood. Whenever we are creating a Delta Lake table, it is creating with Apache Spark. So you can use any feature which you are using with Apache Spark. Schema evaluation, which is quite important. Parquet files, if you are familiar with Parquet files, you know that changing schema is not very good. Let's say you can end up with a lot of problems, a lot of issues. But Delta Lake supports schema evaluation by default. And if you are working some kind of enterprise, you need to audit history. And yes, we can do it with Delta Lake by default. We don't need to add some kind of extra features to the database like we do in Hive. No, it's there by nature. And this is very critical for me. For example, it supports upsort and delays. I mean you don't need to do anything. You just create a merge command and that's all. If you are not familiar with what is upsort, it's update and insert. So if it's found, you are doing update. If it's not, you are inserting new records. And it supports delays. Also, Delta Lake has native support for HDFS, AWS, and Azure. So whatever you have right now today, you can use it with your current setup. So why we should switch to Delta Lake? Like I said, ACID is quite important. If you need some kind of ACID transactions, Delta Lake is a good option. Or if you need time travel, time travel is important when you are working with machine learning libraries because you need to see what was the data when this model has run. Right? You need to know that, and you need to understand why you see this output. That's why we need to have this data versioning. And the most important thing that right now Delta Lake is a lot faster, as you can see in this graph, a lot faster than the competitors. Like it's faster than if you use Vanilla Hive or if you use Parquet. This is why we are offering the Delta Lake for today. Okay, now it's time for a demo. Let's continue. Okay, so this is our Zeppelin. For today's demo, we will be using the Zeppelin notebooks because it's quite fast and good for visualization, right? And let's see. First, I would like to start deleting whatever left over from my last test. Okay, so this is the first entry of Spark. What we do, we are creating an range for us starting from 0 till 5, and we will write it to our Delta Lake. That's all. As you can see, it's very simple and very easy. We just need to put data, write format, and Delta. Nothing more. We are specifying the location, and it is saving it for us to our location. And default location is HDFS. So I have up and running HDFS. If I go there, let's go there, and yes, please go to TMP because I have created under TMP, and if I check Delta Lake, it will be already there, right? Which is perfectly fine for me. Okay, let's continue. And now the next step, I write data to this Delta Lake, but I would like to read it. Is that hard? No, the answer is it is very easy. We just need to read, and we just need to define the format. It was like format Parquet whenever we are saving, and format Parquet whenever we were reading before, when we were using only Parquet. And now instead of Parquet, we are doing Delta, and we are getting the data from 0 till 5. So let's continue. Yes, we read and we write. There's no issue. And I would like to overwrite the table, and I would like to change my range from 5 till 10. Can we do it? Yes, we did it without any issue. But we had records. Now what happened? We just destroyed this part. 0 to 4. We have 5 to 10 till 10. Okay, that's good. We have some data. Now I would like to do some changes. For example, I would like to do an update. Can I do it? By default, yes, we can. There's no issue. So our condition is, a module operation. We are defining some condition with expression, and if it fits, we are doing a set operation. So basically, we will add 100. Then I would like to delete some of those records, like with the same filter. Can I do it? Yes. And I will be creating new range as a data frame, and I will merge into my table whatever I had. As you can see, merge operation is very simple and very easy. It is just merge. If it's matched, I am doing an update. If it's not, I am doing an insert. So basically, this operation called as absurd, if you are not familiar with. At the end, we will show the last result of this data table. As you can see, we have those records. Perfect. So, but I would like to, see some versions. What has changed? Is that possible by default? Yes. So do you remember the first version of our table? We had 0 till 5, and it's there. So basically we did it. Let's change the version and let's see the second version of this table. Yes, it is also there. Can I see another version? Yes. So this is the operation when we add 100. It is also there. So this is, can you imagine that when you are doing some changes and you change something accidentally, and you can still get the version and you can see what was the data, right? Okay, now I would like to start something more complicated. I would like to create a structured streaming and I would like to directly send it to table. Is that possible? The answer is yes. We can create a structured streaming or we can use structured streaming to stream inside to Delta Lake. Let's do that. Whenever I do that, I can go and check my Spark UI. If you are not familiar with Spark UI, it is publishing from port 4040 by default, and I just need to check the structured streaming. Yes, something is running. So we know that we are writing to this TMP Delta table. Let's try to read it. Also, I will read it by structured streaming. So I am able to write to structured stream to Delta Lake table via structured streaming, and also I can read it in manner of the streaming format. So let's check. And I have defined my my output as stream2, and I'm writing SQL query, querying it, and whenever I get count, it is increasing because it's streaming right now. Okay, but how it's growing? Let's see. I am getting an ID and count, and I am grouping, and I'm ordering by count. So basically, we have 17 two times. Okay, let's stop the streaming part because we will circle back to this one in next slides. Let's stop it, and as you can see, everything just stopped. Now, I would like to see the history of this table. What has changed? When? By whom? And whenever working with the enterprise, this is quite important. Right now, it is now because I didn't configure it, but we can see that this table has 48 versions. It means that at least there are some changes. No, not some. There were 48 changes on this table, and we can see what was the operation. For example, the last operations are streaming update. So we know that some stream came here and just updated. And also we can see operation parameters, who and which query was running, and we can see operation metrics. So basically num output rows, it means that we were changing two rows. For this one row. And so let's go to the very beginning.
Safak, we have a question regarding whether it is possible to refer to the version not by version number, but by the time.
The answer is yes. The answer is yes. We can specify, instead of version number, we can give the version time, and it will give us the data snapshot on exactly given date.
Okay, thanks.
Okay, so let's say, for example, there was some delete operation, and if I set up the user ID, I would be able to see who did the deletion, and if somebody needs to be blamed, we can blame him or her. Right? This is quite important. Okay, so let's see. And what else? Read version, it also gives us the read version. So it's checking what was the previous version. Like I said, if let's imagine that you run an algorithm and you got unexpected output and you run it today and the results are totally different. You can check the data versions between that day and today. Then you can see what was wrong or what has changed. And also I would like to see the detail of this table. Let's see. Whenever I do, this is still SQL query, whenever I do describe detail, I'm able to see this format is delta. I can see the location. And also I can see number of files, 93. So it is too much, right? Because we don't have more than 100 rows, but still we have 93 files. What happened? Because this one is not well partitioned. This is for start. This is just sample one. As you can see, I told you this is the HDFS table. As you can see, this is running on my local host, and this is my address. So let's check the folder. When I check the folder, I see that Snappy is enabled, and there are several Parquet files, like 93. And also I am having another folder, Delta log. What is this? Why we have Delta log? Let's see. If I go to Delta log folder, I see there are JSONs, checkpoints, and so on. It is interesting, right? We need to see what is inside of these JSON files. Let's go. I would like to see the first version. Now it makes sense, right? It shows us that what has changed on this version. So this is the version 0, I mean the first version, and it says that 6 files have been affected, and we are also able to see which files are there for the version 1. I mean, if we would like to read version 1, first version, we need to go through those Parquet files, and that's all. Okay, let's see. I am referring Parquet files. Is that possible to read only Parquets? Should be, right? What could go wrong? Let's see. And yes, voila, we are able to see the Parquet, but right now we are reading all. So it means that whatever we have in this folder, we are reading it as a Parquet file without any issue. But we lost the versioning and time travel options and merge schema because it's just simple Parquet. Okay, so I would like to, we are talking about schema change. I would like to add one new column and read it to table, right? So basically, I will read as a data frame from the location. I will add new column, and I will write it the same location because it supports schema evaluation. Let's see. We got an error, analysis exception, right? A schema mismatch detected. So, but we were talking that it should be supported. Yes, and it also gives us a hint. If you would like to use it, you need to set schema merge option as true. Okay, the next set does it. We have schema merge and it is appending, and let's see. Okay, now everything worked. I would like to see the results. Voila, we have once for all, and we just did schema change without any issue, and we read it. And the last comment which I would like to mention, the vacuum. So basically each we can give retention for the data, and whenever we run this vacuum, it will clean out the old data, I mean older data for defined in retention period. Default is 7 days, so if I run it, it will clean the data older than 7 days. But you know, this is manual operation, and you need to do it once you have too much data, or small files or something like that. It's not regular operation, and you don't need to do it every day, right? Now, any questions so far?
At the moment, we do not have any additional questions.
Okay, that's great. So let's continue with structured streaming. I need to start play from current slide. Yes. Okay, now we will be talking about structured streaming. But before we start structured streaming, we need to talk about what is streaming and Spark streaming. So streaming is basically the data in motion, right? We are getting the data from somewhere, some location. It could be any. Then we need to process it, and we need to create some insights, some analytical functions, and so on, and put it into some location. This is the overall definition of the streaming. Then we have Spark streaming, but this is older version of streaming for Spark. How it works? It works in micro batches, where we are able to get the data from Kafka, Flume, Kinesis, Twitter, whatever we choose, and do the micro batches and save it to some location. Whenever I say micro batches, I'm talking about time windows. Whenever we are defining our streaming, we need to give that, okay, please aggregate the data in every 5 seconds or every minute and send it to some location. Do the analytical part and send it to location. This was the best. Like I said, it was working with micro batches and it is processing data. Today, we have structured streaming. It is fast, scalable, fault tolerant, and it supports exactly once semantic. This is quite important for us. So what has changed? As I mentioned, it was like batch processing, but today we have something called continuous processing. Whenever Spark gets a new data, it stores in a location which is called unbounded table for us. It could be on memory or it could be some location, right? If we would like to have it as fast as possible, it will be in memory. And this system guarantees that there will be exactly once delivery. What does it mean? We got a message from some location and we should get this message only once and we should deliver it to target only one time. There are several approaches like at least once or at least once or exactly once. So at least once means that we will get message at least one time, but there could be duplication. But structured streaming guarantees that we will get it exactly once. Every data item which arrives to us will be new row in this table. It is just interesting, right? You have a real-time table and you are able to query it. Okay, so let's talk about this timeline. So at T1, we are getting a data and we are querying it, we are doing some analytical operations, and we see the output in complete mode. First, let's talk about output modes. What does it mean? Why it is complete? Complete mode that in the output part, we will be seeing whole data, but it only works with aggregation because this complete of data could be huge, right? And append mode. Append mode is just appending new lines to the table like we discussed. Whenever we get the complete, this unbounded table will be destroyed and recreated with new set of data. And whenever we are working with append, we are just appending new records to this table. And the third mode is update mode. If there's a record in this table, we are just updating the result. It could be count, it could be something. But if it's not found, it is just inserting new line. Okay? So let's go back this timeline. At T1, we get new input, we did the calculation, and the output didn't change because we are doing, for example, we are getting duplicated records. At T3, we still have the same data. I mean, not same, but duplicated data, but output is still same because this is working on complete mode. I mean, we already grouped the data and we are seeing the same. Now, one of today's example, of course, word count. Without word count, there's no Spark. So let's check the timeline. This also works on complete mode. So at T1, we are sending cat, dog, and dog. So basically 4 words. And whenever we do the count, we are getting the result cat1, dog 3. And the output table will be look like exactly that. And at T2, there was some time after, we are doing all cat, and now the query updated. We see cat2, duck3, all 1. But we did calculations again because we need to do for complete mode. And we have duck all at T3. So basically this is our input table and the result table is cat2, duck4, all 2. And we have 4 built-in sources as of today: file source, Kafka source, socket source, and RAID source. File source is like we are able to stream in from a file without any issue. Kafka source is the most used and most required one, I would say. We are able to get the data from Kafka, and we have 2 more sources, socket and RAID. They are only for testing purposes. We are not using, you can use, but not recommended in production environment, right? Okay, now I would like to talk about something called window operation. Whenever we are working streaming, any streaming technology, you can define a window, processing window. So basically in here, our window will be 10 minutes and we will be sliding it every 5 minutes. So once we get two messages at 12.2 and 12.3, at 12.5, our result table will look like this. At 12.10, we moved this slide, but your window is still 12 to 12.10, and then this result table in the second part. Then we moved one more time to make calculations and so on. So when it's this window operation is useful when you like to see, for example, error messages for last 24 hours, and you are moving the window with every hour. So it means that you are checking the last 24 hours messages and you are doing the calculation every 1 hour, right? Okay, so this is the late arriving data. What does it mean? Let's assume that you are sending some messages and still the processing time is 5 minutes and your window is 10 minutes. So it means that if you arrive a message around 12:24 from the 12:4, like donkey in here, it means that this message will be ignored, because it may affect your calculations. For example, let's assume that we were checking error messages for last 24 hours, right? And our sliding window for 1 hour. So we checked these messages and there's no error. And there were some device which was offline for last 3 days. Then suddenly it became online and you started to get messages for last 3 days. And if you also calculate those last 3 days messages, it may cause a calculation issue and you may get wrong errors, because we know that it was already offline for the last 3 days and we shouldn't do the calculation. And this is what we have late arriving messages handling. And we need to do watermarking. When I say watermarking, we need to know when this data has been produced, and when it has arrived to us. Okay, now the demo part. Yeah, please.
Like we have two questions. First question is a late question regarding the data lake. The question is about multi-table transactions, whether it is supported in data lake or not.
Multi-table transactions are, I mean, if we are doing the transactions separately, yes, they are allowed. But if you would like to do, for example, insert into, you cannot insert into with. To see with streaming, yes, you can. You can do you can insert the same stream several tables at the same time without any issue. But if you are referring joining from multiple delta lake tables, for timing, 2 tables are supported.
Okay, thanks. And another question regarding the streaming case, and Vladimir is asking whether you have an experience with Kapci real-time streaming for historical analytics.
If we are referring Kafka's Connect or Kafka's KeySQL, I am familiar with it, but I didn't use them in production. But structured streaming I used in production.
And second question: how did you manage late arrival? But I guess you already covered this right now. So please, Vladimir, if it's not enough. Okay. Have you worked with a use case where Kapci real-time stream output were used for historical analytics as well?
Historical is quite dangerous word, because whenever we say historical, if you are referring like 1 year or 2 years of data, the only way to do it, for example, with structured streaming, we are able to join historical data with stream, and also we can even do that stream joins. Structured streaming is support this operation. But like I said, the historical join is supported, and yes, I did join with structured streaming with one historical table, if this is the question. But whenever we say Kappa, if it's referring Kappa architecture or Kafka Connects.
Okay, and how did you manage to handle later arrival in this case?
Later, still watermarking. This is the only solution for the handling with late arriving messages. Apart from that, you need to write your own logic, and whenever you try to implement something by yourself, it may cause the calculation issues. So I exactly use this what is defined in this slide. I did the watermarking, and in my case, the window was like 24 hours. I was working for some green energy company, and we moved the window with 5 seconds, but they would like to do the window for 24 hours, and they also want us to join the data from their data warehouse. It was MS SQL, and we did it.
Okay, thank you very much.
Okay, let's go for the demo part. Structured streaming. Yes, so before we start, I would like to, restart my Spark, not to have any issues. I believe everybody knows Murphy laws. If something could go wrong, it will definitely go wrong. So let's be cautious. Okay, so this is how we start with the structured streaming. As you can see, this is word count example. But before we start this one, we need to connect the socket. So it means that this socket should be up and running in terminal. For this terminal, I'm using directly netcat, and I can show it to you. It is there, it is working, NC LK 9999. So basically, I am defining the format, I am giving the host and the port. That's all. This is the simple definition of the structured streaming. But if I run this, something will start? No, because it needs to have the start query part. So let's continue with this one. We will be reading stream. We are giving the definition. Then we are also defining our aggregation functions. We will get the lines as string. We will do a flat map because, as you remember, if there are some spaces, we will clean them out and we will get as a flat map. Then we will group by and get the count. Okay, perfect. Then, like I said, I did it. And let's check if anything is running. As you can see, there is no structured streaming tab. It means that our streaming hasn't started yet. And it requires me to run this start query. So I am also defining the output location. It could be, I am giving the format as memory, and as you can see, output mode as complete. I cannot use, I cannot use complete mode without any aggregation. And that's why I am running it, and I am giving a query name as word counts. Perfect. Let's see if anything is up and running. Yes, we got the structured streaming, and we see that something is running. Perfect. Let's try. Let's try to get a count, right? Let's try to see if anything is there. No, it is, for now, it is an empty table. If you remember this unbounded table and result table, right now it is totally empty, and I would like to send some test. Let's try to do this one. Let's do dog and all. Yeah, it was a good example. Cat, dog. Yeah. So let's see one more time our table. Now, yes, we have some examples. Perfect. And the first batch run did it, and then we saw the second batch also ran, and dog has been updated. Right? Let's see our structured streaming things one more time. As you can see, we are able to see records are coming, and it is showing us batch duration and so on. Okay, this is perfectly fine. So we know that word count is running for us. So let's get more complicated stuff, right? Today, like I said, we will be using this OpenSky data, OpenSky network data, which is aviation data. And this is really, really good for us. Yes, I don't know why we are not able to see that. Yes, now we are able to see it. Okay, let me give you briefly what is OpenSky network. Whenever we are, if anybody, I believe everybody knows what is flight radar. right? Flight radar is the place where you can track your flight or any flight in the world. So basically, OpenSky network is the same, but it is open source, so anyone can use it for free, and they have very good Python, Java, and REST API. So basically, we will be getting real life data from their systems. That's all. We will be getting the data and we will be streaming it for our purposes, because by default, you need to pull the data from them and you need to stream it. For these purposes, we will be using one Python script, which is generated by me. As you can see, my credentials. Don't worry, after this webinar, I will change them. So as you can see, we will get the data and we will send it to our Kafka broker. And I have up and running Kafka broker and Zookeeper to see these details. Okay, let's run our structured streaming. So what we have done, we have defined our stream as a read stream. As you can see, we give the format. It was Socket before, now it is Kafka. And we need to give this bootstrap locations, and we need to define which topic we would like to listen, right? Then I have defined a schema because my data is it's a very big JSON. Let me show it to you as well. This is how my data looks like. As you can see, one big JSON, not one big, but each line, let me do this. Each line is a one JSON object, which is a location, which is a data directly coming from the airplane for us. And I don't want to see like that. I would like to see more structured. So this is why I defined a schema. Then I am using a very good function which is called from.json. Whenever I do that, and I am giving the schema, and it will convert it more structured type for me. And now this is the part which I am able to start structured streaming. But instead of the continuous processing, I would like to use some kind of 30 seconds batch. Is that possible? Yes, it is possible. And in here, we will be using, for the sake of speed, let's not do the 30, but let's do 10 seconds. So each 10 seconds, it will do the calculation, and it will send the data in memory in append mode for us. So right now the streaming has started. Let's see if anything is up and running in structured streaming. As you can see, word counts has finished because I stopped, and query to 8 is running for time being. So it means that it is doing some calculations. And as you can see, we already get around, I don't know, more than 5,000 records. So if I query with SQL, it should be good, right? Yes, we have some records. Yay, perfect. We are getting real life data from real airplanes. So if you go to Flight Radar and check for this call sign, you will see it. Okay, but still it's not what I wish. This is just getting data, and this is not very useful for me. So I would like to stop this one to continue next steps. I would like to, I have some domain knowledge. I know that the data on ground means that the plane is on the ground, literally, and this is not good. I would like to see the flights which are already flying, and I would like to group by them, country, and their ICO codes. So, and then at that, I will do a count. As you remember, this is an aggregation operation. So I can use the complete mode because I know that whatever comes to me, it will fit in my memory. So I'm also giving starting offset as latest. So I know that I will be getting the data where the end has there. The endpoint is there. So let me try to restart. Yes, now it is up and running. Let's see. Structure streaming query tree is also running. Let's see. Let's try to query. Let's try to get a count. How many messages? 0 yet. So come on. we are still not processing. Let's see. Still running. Probably my batch time is 30 seconds and I forgot to change. So guys, we need to wait a little bit further to complete this processing. Still 0. Now it's doing something. So it means that we have some records. No, not yet. Now we have 5,000 records. Perfect. And let's see. Let's do the group by. And so basically we have Peru and we are getting this plane and we have one message so far. That's nice. And now I would like to see the distinct count. How many messages I am getting from which countries. For example, I am getting 3,500 messages. Let me rephrase the saying. I have 3,500 planes on the air in United States for now. And I have like 126 planes in China. This is how I visualize by limit 10 and grouped by origin country. And I would like to stop the query. So did I lose the table in memory? Let's see. As you can see, the table is still there, but as a state, because it won't be updated anymore. There is no running query for this structured streaming for time being. So if I continue running it, I will always get the same result. Okay, perfect. Let's go our real life use case. I would like to see the planes. For example, I am a business guy and I would like to see the emergencies over the air. Is that possible? Yes, we can do that. Let's restart our kernel one more time. And whenever I refer emergencies, there's something called emergency state on the flight. We know that these SCAV codes, and we would like to use those SCAV codes. For example, I will come to this point when I run it. So let's wait for this explanation. Let's do the first, our engineering part, streaming. So I need to define a stream, yes, and I need to define a schema to use from JSON stuff, right? Then there's something new. I can define a very well defined schema case class for me in Scala, and then my data frame became a dataset, which is also checks the types in compile time. Let's try to run it. Right now, we have just defined a generic streaming for the dataset, but we haven't started it yet. To start it, we need to run this one. It will give us ability to query this streaming. And as you can see, output mode is append. So basically, we will be attending new lines to the end, and our format will be memory. So we will be able to see it in memory. And processing time will be 5 seconds. So with every 5 seconds, we will be seeing new results. Instead of continuous streaming, I am using the micro batch. As you can see, we are already up and running streaming. And let's see, we didn't get any messages yet. We are still waiting. There should be, come on. Yes, batch duration, there's something. Let's wait and let's go our query part. I defined the name as query, so I am able to query with select star from query. And let's recheck why we are not getting any messages. Let's check if our PyCharm is still up and running. Yes, it is. So there is one thing which I made wrong, maybe the topic name. Let's recheck. Let's be sure. Subscribe sky_data. So everything looks valid. Why we are not getting messages? Let's see. Yes, 5 seconds processing time, query, yes. As I mentioned, if anything could go wrong, definitely will go wrong in presentations, in demo. But the good news that, as you can see, we have the schema in place. what I'm going to do, if we don't get any messages soon, I will just restart my kernel. Probably something is blocking me. Okay, let's stop this query and let's try to rerun it. Okay, restart the Spark kernel. Yes, interpreter stopped. And restart, pending. Okay, we can continue while we are waiting. We will be doing some queries, and I was talking about this 77s, 7000s, I would say. In aviation, they are quite important. If there's a squawk code with 7500, it means that there's a radio failure. If it's 7600, is hijacking, and 77 is any emergencies, right? So basically, I would like to see these details in my dataset, if there are any in real life, in real time. Let's see if it's there. I will be moving there. No, I will just increase the duration to 20 seconds, let's say. Yes, maybe my memory is not just enough. Could be the case. Okay, now let's go and let's check. Structure streaming, it is running. Now we are getting some messages. Yay, we are back online. Okay, let's do the query. And when we do the query, this is real-time querying. So basically whatever we get, it is coming, we are checking to real-time processing. So, and this is the counts which we are getting. For example, we got 4 count from this airplane. Also, I believe I need to mention about ADSB as well. ADSB is the state where the plane is. So basically, and this plane sending this real life data very frequently. So within a second, you may get more than 5 messages from one airplane, because it needs to give the velocity, heading, speed, altitude, and so on. So basically, these are very accurate and very real. So far, for example, for several airplanes, we are getting 4 messages, right? Okay, so I would like to see where this airplane is. Let's copy and let's paste it. Okay, and as you can see, I'm able to create some maps, some cool maps. Yeah, and we know that this probably in United States. We got 4 messages from this airplane, and it is probably yes, close to Las Vegas, Lake Havasu. Interesting. Let's see if we are getting more messages for any of it. For this one, we have 6 messages. Let's see where this plane is. Also, it's in United States. Exact. And each point, each dot in our map is the ICO. It's an airplane, and we know the time. So basically, we know that 54, 53. So basically, this airplane started to send messages to us. And right now, the last message arrived from here. Perfect. And like I said, I am a business guy, and I would like to see if there are any emergencies, any issues over on the air right now. Okay, we are lucky. We have no emergencies so far. Okay, let's stop it. We will come back to this one because I saved huge amount of data and to just show you these queries. But for now, I would like to save it to a table, delta table. Is that possible? We have seen in previous example, previous demo, yes, this is possible, and we can write it directly from the streaming to delta table. And right now we have started. Let's go our structure streaming tab, and as we can see, SkyStream is writing right now. So basically it is up and running, and it means that we are saving our data to delta table without any issue. Okay, I would like to query this table with the SQL, but I don't want to read as a, the structure streaming manner. I would like to use this table as a real table. Let's do the read format, and to right now we have this number in this table. Let's check if there were any emergencies back then. And yes, there was. And one of these planes sent huge amount of emergency. Let's see, it is flight path. I would like to see where was it, when was it, and so on. So let's put our ICO code in there and let's see the flight. Okay, basically it is somewhere in Florida. Yeah. And this is the messages which we get from this airplane. So basically at some point there was some blackout, we don't know. Maybe we lost the coverage. But apart from that, we know that this plane came here to a circle, not circle, a reverse U shape, and then it has ended. The flight has ended, or we just lost the coverage again. We don't know. But we know that we are able to see emergencies and we are able to write the data to Delta Lake easily. Let's continue. Now I can also read the data from Delta in streaming manner, but there's one catch thing. My memory is not enough to read whole data from this Delta Lake to append mode into my memory. It is always failing. So I'm not going to show it to you guys, but it is possible and you can do that. Right now, writer query is still up and running. And this is the end of my presentation. Any questions?
Yeah, please. We have several questions. So first of all, you mentioned the late received data that could be filtered out by watermarking, right? But the question is, is it possible, and how can I separate this kind of data in my processing? So, for example, I would like to, by default, all the late received data are just discarded, right? But is it possible somehow to create a dedicated processing pipeline for this late arrival data?
Let's think. Yes, that's possible, but then you need to do it by manual. I mean, there could be two streaming, one streaming to get to process regularly with window operation and with watermarking. So you will get only the data what you need, and then you can set up the second streaming process. You don't need to filter out this data with watermarking. You will be getting whole streaming data. Then you will be just filtering what you have processed. And even better, you can join two streams and you can say that, okay, please omit or ignore the process already has been recorded. This is possible, and but it requires some kind of custom implementation for the old records.
Okay, so basically creating a my stream with watermarking and independent stream that is responsible for handling late received data, right?
Exactly.
Okay, got it. Thanks.
Do we have any other questions?
Yeah, another question, basically, it is similar to this. The question is the following. Spark structured streaming does not support an update mode on streaming stream joins, stream to stream join. Only append mode. So that means that no output, you're not going to get an output until Windows end time plus watermark threshold. So that means that but late arrival could be in several hours, could be and what is the solution in that case?
Could you please repeat the question, because
it is not like a question, but it's an starting point for open discussion. So you have a stream to stream join,
yes.
And Spark structure does not support an update mode. It supports only append mode. So in append mode, you are not going to get any output until end of the windows plus watermark threshold.
Okay. Done.
Watermark should be less than few minutes, while late arrival may be up to few hours. And what solution do you see in this case? So as far as I understand,
okay, so basically we can dump the newcomer data with late arriving directly. Like I said, we can have two streaming, one structured streaming to get the the data with watermark with everything. I mean with everything, with every feature. Then the second structured streaming directly dumps the data some table, and we can merge them in joins between stream to table joins. Then we can do the processing. This could be also the case, but there is no other way to doing it, to either joining or to implementing some custom calculations, at least for today.
Okay, thank you very much for the answer. And we have a comment from Matthews.
Yes. Yes. I got the comment, so I just changed. So basically, guys, I was wrong about scope codes. Thanks for notifying us, Mitten, and I did the change.
Okay, at the moment, we do not have any additional questions.
Okay, so if we don't have anything, that was all. Thank you so much for attending our today's webinar. And if you have any questions, you can ping me directly.